Alright, geometry fans, so today we're going to look at more angle relationships. That's going to be the name of our topic for today. So the objectives after this lesson, students should be able to, first of all, identify angle relationships, and then two, use angle relationships to set up an equation and solve for a variable or angle. So we're going to start in part one here. You've got this picture. And you've got two angles. You have angle 1, you have angle 2. Notice that both the angles have the same vertex, and they also share this side, this ray. So they both have the same ray, they both have the same vertex. Now what's different about them is that the other rays are going in opposite directions. So first of all, we would say that angle 1 and angle 2 are adjacent. And what that word basically means is next to. If you're sitting next to somebody, you could say you are adjacent to them. Okay, so angle 1 and angle 2 are adjacent angles. Now, we're going to measure these, and we're going to use a protractor. So you can get a protractor from your teacher, and we're going to measure angle 1, we're going to measure angle 2. Now, what I've done here, I've copied the angle onto a separate piece of paper. You don't need to do this, but the reason I did it is because with all the writing and stuff up above here, it's going to be very confusing for you to see my numbers, to see my values. So with the protractor, okay, when you look at the protractor, you'll notice that in the center at the bottom here, you have, this is kind of like a cross, a vertical line and a horizontal line that go through this circle, this open circle right here at the bottom. Then you have at the top, you have all these numbers. Now, from left to right, I start here at 0, the top numbers 10, 20, 30, 40, 50, all the way around, and then down here, 160, 170, 180. Those are degree measures. But notice that the bottom numbers are the exact same, except they're going the opposite direction. Well, sometimes you use the top number, sometimes you use the bottom number. It all depends on which direction your angle is going in. For example, I'm going to start with angle 2. And what I'm going to do is I'm going to take the hole, this hole of the protractor, I'm going to put it on the vertex. Now the horizontal line, okay, if you look below, here's the horizontal line. I'm going to line that up with the ray of the angle. So here's angle 2. Here's the vertex, and then here's the ray at the bottom. Notice that it's in line with it's lined up with my horizontal line. And the arrow is pointing towards over here. This is like 0 degrees, okay, at the bottom. So I'm going to go 0, 10. I'm going to use the bottom numbers, 20, 30, 40, 50. Now if I continue this, I'm going to approximate a little bit here. The question is, where does it hit the protractor? Where does this other ray hit the protractor? You can see that it's between 50 and 60. Now, I'm going to estimate, I'm going to approximate, I'd say it's about 54 degrees. Okay, so what I'll do for angle 2, I'm going to write here 54 degrees. Now for angle 1, I'm going to set it up the same way. I'm going to put the whole of the protractor on the point, on the vertex. Now I'm going to line up again the horizontal line. This time though, I'm going to use for angle 1, the bottom side is the left. It's going to the left. The arrow is pointing left. So I'm going to think of this as 0. I'm going to use my top numbers, 10, 20, 30, and so on. All right, so let me line this up again. Now, I have the bottom line, which is going over to 0. Then I have, here's the other ray. Again, it's going to hit in the same place on the protractor, except now I'm using the numbers at the top. So right about there. Now if I look at that on the protractor, it looks like 120, 125, a little bit more, maybe 126 degrees. So this is 126 degrees. Now what we'll do, let's go back to the paper, the notes that you have. So we had angle 1 was 126 degrees, and then angle 2 is 54 degrees. Now notice they're not the same. They're not congruent. Angle 1 is obviously obtuse. Angle 2 is acute. So they're not the same. However, if I take 126 and I add 54, I get 180 degrees. Now 180 is a big number in geometry, and this should actually make some sense, because if I trace out angle 1, I'm going to trace that in red, and then if I trace out angle 2 in blue, now notice that both angles have the same vertex, they have the same ray here, but the rays at the bottom, they're going opposite directions, and they are linear. They're collinear, basically. So they form a straight line. Well, yesterday you learned that a straight line, a straight angle, is always 180 degrees. So they should add up to 180. So we have two vocabulary names for this. First of all, we can call this a linear pair. Two adjacent angles that form a line. They're next to each other, and they form a straight line. That's 180, linear pair. Now, anytime you have two angles whose sum of degree measure is 180, we say that they are supplementary. They are supplementary angles. We can say that the measure of angle 1 plus the measure of angle 2 equals 180 degrees. That's supplementary. Okay, now, one of the ways that I remember this, well, next time you're walking down the hall and your friend comes up to you and says, "Sup?" with a question mark, all you have to do is answer 180. Supplementary angles. Sup? 180. That's your math joke for the day right there. Supplementary angles add up to 180. Okay, now let's go down to this next diagram here. You have four angles, 1, 2, 3, 4. One thing I want you to notice here is that if I only look at 1 and 2, that's a straight line. They create a straight line here. They're adjacent. That's a linear pair. They are supplementary. They add up to 180. How about angle 4 and angle 1? That's another linear pair. You see the straight line right here? How about angle 2 and angle 3? Another linear pair. How about angle 3 and angle 4? So you have all these linear pairs. Now, I'm not going to use the protractor on this, but what you're going to find when you measure this is that angle 1 is about 135 degrees, angle 2 is 45, angle 3 is 135 degrees, angle 4 is 45 degrees. Now you have all these relationships that add up to 180, 135 and 45. So supplementary angles, supplementary. You could say angle 1 and angle 2 are supplementary because they add up to 180. Angle 2 and angle 3, those two add up to 180. Angle 3 and angle 4 add up to 180. And finally, angle 4 and angle 1. You have four pairs of supplementary angles. But the other thing that I want you to notice, not just that you have measurements that add up to 180, you have measurements that are actually equal to each other. For example, angle 1 is 135 degrees, angle 3 is 135 degrees. Now when I label angles, I label them with arcs if they're congruent. One arc, those are the same. Off on the side here, angle 1 is congruent to angle 3. At the same time, notice angle 4 is 45 degrees. Angle 2 is also 45 degrees. Those are congruent. So I'm going to label those with two arcs. The reason I'm going to use two arcs is to show that they are not the same as angle 1 and angle 3. These are congruent to each other, but not to these two. So angle 4 is congruent to angle 2. So when two lines intersect, when two lines cross, you have all these relationships. You have 180 degrees. You also have angles that are congruent, where their measurements are equal to each other. the measures that are equal, what we call this is we say that these are vertical angles. Now, the definition is two non-adjacent angles formed by intersecting lines. What that means is this. When two lines cross, non-adjacent means that, okay, yes, they have the same vertex, but they're not next to each other. It's almost like they're opposite each other. So those two are congruent. If I draw the same picture, I can also say these two are congruent. Those are vertical angles. That's a pair of vertical angles, and here's a pair of vertical angles. Vertical angles are always congruent. Always congruent. So supplementary means they add up to 180. Vertical angles, they have to be congruent. Now what we'll do, go ahead and flip your notes over. And this is the end of part 1, and we'll get to part 2 next.